Hey, Dia here, and welcome to the intermission, where we take a break from the pseudo focus series with a quote unquote simply complicated problem that I thought of 2 years ago. Oh, and by quote unquote take a break, I mean end up using quote unquote 100% of brain to a math problem in comparison to the other episodes where you barely use any brain at all. Here we have a semicircle of base 12 and then a rectangle of same base, where the side inside the circle is 7. In this problem, you must find the green area and the red area. Pause this video and try if you can figure this out. Alright, for the green area, let us start by drawing two radii connecting the two shapes' intersection. By drawing these lines, we can visualize that this green area is simply the arc's area minus this triangle. With that idea in mind, let's take on a triangle. Two sides of the shape are just the radii, whose measures are 6, which is half the semicircle base. Moreover, this triangle's base is simply 7. Using the sides, we can either divide this triangle or use the law of cosines to find this bottom angle measurement. I use the law of cosines, where we have c squared equals a squared plus b squared minus 2ab cosine of big C, where c is 7, a and b are 6, and big C is the angle we need. Doing the algebra of this equation, we will get 49 equals 36 plus 36 minus 2 times 36 times cosine of big C. Next, we combine the 36's to 72 and multiply 2 and 36 to 72. Afterwards, we factor 72 on the right, where the inner factor will be 1 minus cosine big C. Following that, we divide the 72. Then, we isolate cosine of big C, where we have 1 minus 49 over 72 to the other side. Next, we take the inverse cosine of that other side. And lastly, simplify 1 minus 49 over 72, where we end up with inverse cosine 23 over 72 for big C, which is approximately 71.371 degrees. With this angle at hand, we can find this triangle's area using the formula AB over 2 sine of big C, where big C is the angle between A and B. For our case, A and B are 6, and big C is 71.371. Plugging these variables, we get 6 times 6 over 2 times sine of 71.371. Evaluating will give us 18 sine of 71.371, which calculates to 17.057, which is the triangle's area. Next up, we have the arc, where its area is given by pi r squared times theta over 360, where r is the radius 6 and theta is the same as a triangle, 71.371. Plugging them gives us 36 pi times 71.371 over 360. This expression begs for a simplification where we get pi over 10 times 71.371, which is an expression that estimates to 22.42. Now, to find the green area, we can subtract the arc area, 22.42, and the triangle area, 17.057, where we get 5.365 areas, I don't know. And this will be our green area. Next, we find the red area, which is the rectangle's area. The area of the shape is simply base times height, where we clearly have the base of 12. So, we only need the height. To do so, let's go back to the triangle with sides 6, 6, 7, because the triangle's height is also the rectangle's height. To find h, we divide the triangle into two right triangles, where each triangle has a hypotenuse of 6 and a base of 3.5. To find the height, we use the Pythagorean theorem with a squared plus b squared equals c squared, where the hypotenuse c is 6, a is 3.5, and b is the unknown height. Using them, we have 3.5 squared plus h squared equals 6 squared. Arranging this to h squared equals 6 squared plus 3.5 squared, we isolate the h squared. Next, we simply take the square root of the right side, giving root of 6 squared plus 3.5 squared equals h. With a calculator, this yields 4.873. With our height found, we can now find the red area, where we multiply 4.873 to the base of 12, ending up with 58.481, which is the rectangle's area. So, what did you think of the problem I made 2 years ago? Feel free to share this brain melter to your fellow nerds and give them a nice mental
enhanced interrogation.
Make sure to subscribe and like this video, and subscribe to my other garbage channel, Diabeticus, for intelligent memes. See ya!
You're still here? It's over.